Christmas morning, 2015. A kid named Lily unwraps a mysterious black cylinder. No screen, no buttons, no keyboard. Her dad grins and says, "Try talking to it." She says a few words out loud, and music instantly starts playing. How? Think about how strange that is. For your whole life, computers needed you to type, to click, to tap exact buttons. Now this thing just understood her voice, out of thin air. And here's the wild part. Only a few years earlier, this was basically impossible. Hi, I'm Byte. That little speaker wasn't magic. It was the result of a genuine revolution that hit AI in the 2010s. In the next few minutes, I'll show you the exact ingredients, the exact year everything flipped, and why gamers accidentally saved artificial intelligence. Big breakthroughs almost never come from a single invention. They come when a few things collide at the perfect moment. The 2010s AI boom needed exactly 3 ingredients to show up together. Miss anyone, and the magic doesn't happen. Ingredient number 1, massive data. By the 2010s, the internet was flooded with billions of photos, videos, and texts. And an AI is like a student, it can't learn from nothing. It needs mountains of examples. Suddenly, for the first time ever, those mountains existed. Ingredient number 2, super fast chips. Learning from billions of examples means doing a mind-melting number of calculations. Old computers would have taken forever, but a special kind of chip built for video games turned out to be lightning fast for this. Hold that thought. Ingredient number 3, the secret technique, deep learning. It's a method that stacks many layers of learning on top of each other. The idea had been around for decades, but never really worked well. Now, with enough data and speed, it finally clicked. Data plus speed plus deep learning equals revolution. Here's a thing most grown-ups get wrong. When we say deep learning, deep does not mean super smart or mysterious. It literally just means many layers, stacked one on top of another. And this idea is copied straight from something you're using right now, your own brain. Your brain is packed with tiny cells called neurons, arranged in layers that pass signals to each other. Deep learning builds fake versions of those neurons in layers inside a computer. Each layer takes what the layer below found and builds something a little smarter from it. Let's watch it recognize a dog. Layer 1 only sees the simplest stuff, edges and colors. Boring. Layer 2 combines those edges into basic shapes like circles. Still nothing impressive, but we're just getting started. Layer 3 assembles those shapes into parts, an ear here, a nose there, 2 eyes. Layer 4 puts the parts together into a face shape and fur pattern. And layer 5, the very top, finally announces, that's a golden retriever. No single layer is smart. Together, they're brilliant. Think of it like Lego. Layer 1 is loose bricks. Layer 2 builds walls. Layer 3 makes rooms, Layer 4 adds floors, and Layer 5 reveals a complete castle. And the deeper you stack, the smarter the AI gets. More layers, more understanding. And here's what makes LittleAIMaster different. You don't just watch this happen inside the app, you actually stack these layers yourself and watch your own AI slowly learn to see. We don't just teach AI, we hand you the bricks. So how do we know deep learning actually works? Because scientists put it in a contest. It was called the ImageNet Challenge, basically the AI Olympics. Teams from around the world compete to build the AI that can recognize photos most accurately. And this contest had a monster of a dataset. ImageNet held more than 1 million labeled training pictures, sorted into 1,000 categories: dogs, cars, flowers, instruments, you name it. Imagine handing an AI thousands and thousands of photo flashcards and saying, "Study these. Learn what everything looks like." That's the scale we're talking about. For years, the best AIs in this contest were kind of stuck. They'd get about 75% of the images right, and progress crawled forward slowly, year after year. Everyone assumed that's just how it would be, slow and steady. Then September 2012 happened. In September 2012, one team showed up using deep learning and scored 85%. 10 whole points better in a single year, in a contest where people fought over tiny fractions. It was like showing up to a race and finishing before everyone else even left the starting line. Their AI was named AlexNet. And here's the jaw dropper. It studied around 1.2 million ImageNet photos using just 2 gaming graphics cards. 2. That one result cut image recognition errors from about 26% down to 15% in a single leap. The AI world was never the same. Wait, gaming graphics cards? For serious science? Yep. And this is my favorite twist in the whole story. The secret weapon behind the deep learning revolution was a chip that millions of kids were using to play video games. Let me explain why that works. Every computer has a CPU, the main brain. It has just 4 to 8 cores, but they're powerful. Think of it as one expert chef, cooking one incredible dish at a time, perfectly. Great for running your apps, but not great when you need a million things done at once. A GPU, a graphics processing unit, is totally different. Instead of a few strong cores, it has thousands of simple ones. Not one expert chef. Imagine 1,000 helpers, each adding one ingredient at the exact same time. It was built to draw millions of game pixels instantly. And here's the beautiful accident. Deep learning needs millions of small calculations done at the same time, the exact same shape of problem as drawing a video game. A GPU chews through thousands in parallel. So chips built to make dragons look shiny became the engines of artificial intelligence. Nobody planned this. The people making faster gaming chips weren't trying to build AI. The people building AI weren't thinking about games. 2 totally separate worlds crashed together and made history. Technology does that. The biggest leaps often come from the weirdest connections. Once deep learning could see, researchers pointed it at a new challenge: hearing. Understanding a human voice is brutally hard: accents, background noise, mumbling, slang. But the same layered trick that spotted dogs could now untangle sound. And that unlocked something you use all the time. In 2011, Siri arrived on the iPhone, the first voice assistant lots of people actually used. 2012 brought Google Now. 2014 gave us Alexa, the first smart speaker for the home. And in 2016, Google Home put one in living rooms everywhere. 4 years, and talking to your house became normal. And here's the cool part most people never notice. When you talk to a voice assistant, deep learning fires 3 separate times. Once to hear your words as sound, once to understand what you actually mean, and once more to talk back in a natural voice. 3 AIs working in a split second. So now go back to Lily and that black cylinder on Christmas morning. When she spoke and music played, it wasn't magic. It was deep learning hearing her, deep learning understanding her, and deep learning answering, all riding on gaming chips, trained on mountains of data. The whole story in one sentence. This isn't just history, it's in your pocket right now. When you unlock your phone with your face, that's deep learning recognizing you. When a photo filter finds your eyes, that's deep learning. When your streaming app suggests the next show, deep learning learned your taste. Ever typed dog or beach into Google Photos and instantly found pictures you never labeled? That's deep learning, spotting edges, faces, pets, food, and places across your entire photo library, using the exact same layer-by-layer trick as our golden retriever. Small clues stacked into a smart answer. Quick game, which of these uses deep learning? Face unlock, yes. A simple calculator, nope, just plain math. Self-driving car, cameras reading the road? Absolutely yes. A microwave timer, no AI at all. Learning to spot the difference is a real superpower, and it's exactly what you'll practice. Let's put the whole leap on one timeline, because the numbers are genuinely stunning. Back in 2011, before deep learning, the best AI in the ImageNet contest got about 74% of images right. Good, not amazing. Then things exploded. 2012, AlexNet arrives, 85%. 2015, 96%. Now compare that to us. The average human scores about 95% on the very same test. So in 2015, for the first time in history, a computer could recognize images better than a person. Sit with that for a second. In roughly 3 years, AI went from clumsy and slow to outseeing every human on Earth at spotting what's in a picture. That's not a small upgrade. That's the moment machines crossed a line we thought only living brains could cross. Let's lock in 4 power words. Deep learning, AI that stacks many layers to learn patterns, inspired by the brain. Neural network, a computer system wired to work like brain cells. GPU, the chip doing thousands of calculations at once. ImageNet, that giant library of 1 million+ labeled photos. Now here's where you come in. You just learned how AI learned to see. But knowing isn't the goal, building is. Inside LittleAIMaster, you'll stack your own layers, train your own little AI, and watch it learn just like AlexNet did. Don't just use AI, raise one. And you won't stop at layers. You'll create AI projects, write real Python, and see your progress climb the same way that ImageNet accuracy did. Every lesson turns into something you actually make. That's the whole idea, learn it, then build it with your own hands. So remember the recipe. Mountains of data, the right chips, and layers stacked deep. 3 ingredients colliding in the 2010s that taught machines to see and hear. It started with a contest and a couple of gaming cards. It ended with AI that beats us at seeing. You now understand the deep learning revolution better than most adults on the planet. Next up, we jump to AI today, ChatGPT, art-making machines, homework helpers, and where all of this is heading. Keep going, keep building, and I'll see you in the next one. This is Byte, signing off.